And I have my product expert here. We've got this product display with different units. Okay, we have different products from our series production. Let's start at the center. We can see different variants here of positioning systems, different sizes that are always compatible, and we also try to expand this. This is UA version with the lateral tube. Okay, if I wanted to do the UA variant, I can do the lateral positioning, yes. And this is a bracket in the bottom. This is the preferred version for the manual lever system. So in addition to the mechanical stop, it's safely arrested here. Okay, we've already showed this in the most recent show and explained this. And in the meantime, we have 63, 50 and 40 sizes as well. So it's just a cross combination. The stop or the incremental grating, can I use this in other system? Yes, you have this holding valve, or you can have the grating at the bottom. Okay, so it is a parallel clamp which simply sets it down. Yes, we've already done a show on that. We've got a swiveling movement in order to position this. And the tensioning is then done no matter where I am. I can save my sheet metal because I have a complete parallel stroke. Okay, so I do the tensioning with the right tensioning force and no longer use a rotary movement. Okay, it's vertical. Okay, let's remain with a stroke and look at the bottom cylinders. Okay, these are other systems or variants. They've also been developed, become new family members. This is compatible with the NAAMS standard, so the American standard. It's only for the piston rod here. At the right-hand side, it's a larger size, also compliant with the NAAMS standard, also for lateral force, so the pin doesn't have to be in the axis, but can also have an offset. Okay, it looks very robust. Yes, it is. And another benefit, I can my heck-wire connection on all 4 sides. I don't have to decide whether I want to use A10 or A12. So it is secured against rotating, and I can use any connection on any side. Okay, good. In the topmost section, we see different versions. Yes, these are also tensioning systems. This is a vertical clamp, and we have always had inquiries whether we can't do anything more compact. So when I have an underbody clamp, I may have a problem with space. So this is a 90-degree curve, and I have a relatively flat design. So it's a change of direction, and this is where the hook comes out. Yes, it's like a 90-degree system. Yes. When I look at the center design, the pin is a little different. Yes, exactly. And I think we've done a video on that. Exactly. It's a beautiful video that we can make available to you. You can check it out. Okay. Now, the clamp was taken from the testing department. What was it worth? 3 million cycles? No problem. And it doesn't look it, really. I mean, we've just cleaned it, basically. Tightness was still there good, and clamping force was the same as in cycle number 1. And I've got a completely enclosed pin, so it's protected against pollution, contamination, anything. Okay. Very good. Very exciting product. Very, very interesting. Are there any potential applications or different sizes? Yes, there's 40 size design. It's already used in a customer project or already in higher numbers. Okay, size 50 will then be the next size. Yes, for those who can't do with 40. And the optical sensing also, I can use a laser system. Okay, so I can sense here at the bottom. So for geoskids, also quite interesting. Exactly, if I have to use a laser, a cable, and the sensing system, I can use this as well. Very interesting. Okay, let's go on. We've got still some more interesting products for you. Let's look at the center product here. What is this? this is an alpha underbody clamp for different thicknesses of sheet metal. The new thing is the sensing system, and it's also Industry 4.0 compatible. So if the customer doesn't only want to know whether the clamp is open or closed, but wants more information, can get the thickness of the sheet metal and so on. More information. Dual sheet, for example. Can I also get the information that there's no sheet metal in it? Yes, because the pin would be to 0. I would even sense that the hook, for example, is broken. Okay, I can read out the information. What sheet metal is it? No sheet at all. How can I sense all of it? Where do I connect it? I can see the standard sensing here. It's an internal sensing system. So the sensing will be internally onto the unit, and it's all being done via the switch. So Industry 4.0 is really what it's all about. More information. Exactly. Very interesting. Great. Oh, electric controls, and I can see the electric stand. So instead of pneumatic pipes, you have electric wires. Yes, electric clamping has already been done, and we're expanding our variants from 16 to 80. We all have the electric variants now, so that we have many, many variants. Okay, so clamping technology, underbody clamp here again. In the center, this seems to be also new to me, a new design. What about, yes, dual clamps have been existing for a long time, but this is the electrical variant because there was an inquiry by a customer for a different system. Normally they use a pneumatic system, but they wanted to do the electric clamp. Yes, for example, if I transport a sheet metal on a conveyor with a top system, I can actually contact it on both sides. Okay, so normally I have pneumatic pressure lines that are very long. Yes, I mean we have electrification everywhere, so this is why the clamp then becomes part of the electrical system. So it continues in terms of product variants, more and more variants all the time. So the right control, what would it be like? Well, the control system has already been tested, module, whether I have a single clamp or several in the control cabinet. I mean, we are changing this to have up to 8 units in one control cabinet, one central control, and then I can control all 8 clamps. I don't have to have separate supply units and so on. It's all a one-stop shop system, so different controls. Okay, wonderful. And then for electric clamps, what else will be developed? Will there be new developments or new integrations? Yes, the next trend, for example, thickness compensation. I can no longer use a brush motor because I no longer know when the sheet metal comes. You will have to use servo motors with a different control concept also. Okay, now with this variant, the motor is still round and it's connected at the bottom. Will there be any new development? Yes, this is another question that we're dealing with, a smaller variant, so that the width of the motor doesn't have an offset with the pin. So, okay, a large number of variants in production and all compatible with the same control unit. Okay, very simple and easy to operate.
We have many other new products, and while I'm not going to hold anything back, and this is a relatively new product, what are we saying? Well, this is the pneumatic variant of the UP clamp. As I said before, first we swivel this and then I close it. And we can do this also with the servo-electric variant. And as far as the mechanical system is concerned, it's the same parallel movement, but there are many other features, positive features, because of the servo motor. We can see this first, the parallel stroke, the parallel lowering, which we initially explained. Now, in this case, we use an electric motor. What about the controller? Does it really stop at the component? Yeah, this is possible in this case, because the motor can detect the sheet metal, no matter whether it's 1 1 millimeter thick or 3 millimeters, it will detect that more power is required, and then it can then stop where the sheet metal arrives. So it's a very smart control solution. Yeah, I don't have to adjust anything. The motor will see this on its own. And the torque is produced only at the end, or do we have it across the entire movement? That's another advantage, actually. That is, you can adjust the stroke to time or the speed, and it doesn't have a torque then. That is, it's safe. I could also reach in. Nothing would happen. Reaching in means that while it's moving, I can reach in with my hand. Yes, if you want to. Yeah. It can detect the obstacle, that is, more power is needed, and the motor is switched off. And as clamping is concerned, there is a reference sensor which knows, okay, now the clamping will start, and then it will apply torque. Yeah, then you shouldn't reach in, but then it would be only 3 millimeters, so your thumb might become quite flat. And as far as the drive system is concerned, this is a conventional motor. Yeah, because of the sheet metal compensation, we need a servo motor so that we can control it smartly. And we have a different control system here. Yeah, I don't have a plug for the sensor and one for the sensor, but we've got one hybrid cable for the controller. And we are developing some modules for this so that up to 8 clamps can be controlled with one module. So in order to reduce the cable length, for instance, when I have a certain clamp system, yeah, it's a certain gripper system, or I could also connect several boxes in line. Sorry, in series. And so there is a controller piggyback, and do I have more intelligence here? With respect to Industry 4.0, I can program the opening angle. I don't have to do the clamp. I can perform several analyses, produce reports when it's getting slower, when I need more resistance to drive the clamp. So the clamp generates a lot of information which can also be read out at the controller. Yeah, so it will indicate that it's getting a bit weaker. Please check me. I need a check. Yeah, so this is very good for predictive maintenance and also Industry 4.0. Now the control concept is new, but would you also integrate this in other units? Yeah, first for the servo motors, I urgently need it. That is, I cannot use the prior control concept which I showed you before, the DC concept. But DC motors can also be driven with this, and there are also some advantages to this, because I don't have to check the position in the controller. I can do it direct in the clamp, and I have a single cable for the clamp. And I can use this concept for servo motors and DC motors. And this is the same controller for an underbody clamp. Yeah. So this is again a modular design, the same concept, the same controller, the same controller hardware, and I can use it to drive this. And again, a sheet metal thickness compensation, because I need this variant for the compensation. Yeah, that's very interesting, also in terms of Industry 4.0 electrification, and this will probably be the trend in the automotive industry. Yeah, we offer both. That is the normal EK series, which provides electrification, but also other applications where I want to get more information from the controller. Then I can also use the new controller type. Yeah, it's a smart clamping system, very interesting. When we move on, let's stay with pneumatic systems. This is a test station. I know this from the prior symposiums. And what is the drive unit? Yeah, we neglected this. We mentioned this in passing, but we didn't talk about the drive unit. It's also new. It is a double guide cylinder, and in the middle there is a piston rod as a drive system and guide for more stability, that is depending on the type of movement. And in addition to the lateral force and stability, what is another advantage of the unit? Well, it's not only for locating pins, but I can also use this to lift things in all directions, horizontally, vertically. I also have the normal sensing system, the whole pattern, which we know from the normal series, so it's compatible with other units. And also well protected the top, so this is also appropriate for welding applications. Yeah, the sensing system is welding resistant. Now it's extracted, and when I switch it on, I could now clamp the component and lift it. And what is the underlying principle? Well, we have permanent magnets there, which are rotated and thereby switched on and off, and we showed it before. Yeah, this is a very compact clamping concept with this magnet. What is the current state of development? Yeah, we are still making some enhancement. We are improving the power. We have made some improvements to the casing here so that we get a bit more force out of it. So it's optimized, and we are also comparing this with our competitors' products, and we are very competitive. And what we're still waiting for is a sort of variable design. That is, what about the clamping force for several thicknesses with respect to several air gaps, different air gaps, so we are still gaining experience. Yeah, I understand that there is an inductive sensor system in there which will detect the position of the drive unit. How about detecting the components of the sheet metal? Yeah, this is also related to this. When I activate magnets or solenoids, and there are two sheets next to one another, both of them might be lifted up, and we can handle this with the sensor module. That is, the sensor will tell me in the PLC there is no sheet metal or there are two sheets, and it's not integrated in the gripper now because we don't need this application every time. And there are also several units attached to one gripper. And while this technology is a bit more complex, and if I install it every time, it would of course increase costs, and this would be prohibitive. So we try to keep the costs low. Yeah, we want a modular design, and when I have 4 magnetic grippers, then I need, for instance, only one sensor. And if one of these breaks, then I don't have to swap the entire system, but only one of the two. Yeah, that's very interesting. And so we have seen a great many interesting products, and we will look around more. That is, we have prepared much more for you, so stay tuned. It will be very interesting, in particular at the end when we will present the driverless transport system. But there is one new product which I would like to present to you now, briefly. That is our globoidal drive system. Yeah, this is an electric swiveler unit with a globoidal drive unit, as you know it from expert TÜNKERS, the rotary table. So this is a tried and tested technology. We have the experience in the TÜNKERS group, and now it's being applied to the swiveling unit. The globoidal swiveling unit is a bit older for some people, and it's already being used. Yes, there had been a minor disadvantage with respect to safety and redundancy. There is a motor brake which makes sure that the swiveling unit stops in a position, but if I do without the motor, then the globoidal as such wouldn't be self-locking. That is, it could actually move under load. If I want to replace the motor because it's defective, yeah, that would be a problem, but we have solved this because we've got a holding brake in there as a second safety feature. That is, even if I remove the motor and then the motor is gone, however, then the holding brake would engage. And what about if I want to do some maintenance, if there's been a crash or if the motor fails then? Can I then again control the safety brake separately, even if there is no power applied? Yeah, we are developing a solution. That is, if we have removed the motor for maintenance and the swiveling unit is in a position which is unfavorable, then we have modules, that is, which allow me to open the brake with a battery, and I can move the swiveling arm. Yeah. So the operator, the maintenance worker can go in because all this is protected by an additional brake. Yeah, but nevertheless, all this is based on a safety concept and is properly controlled. And how about the control units? What do I need here? Yeah, this is a separate controller for the brake. That's important to know. There are two redundant systems. That is, if the motor breaks or something is not okay in the motor circuit, I will still have the safety brake. And as I said, in the case of a power failure, that is, if no power is applied, if no voltage is applied, then the brake would immediately engage and the swivel unit would be locked. That's very interesting. How about the sizes? This is the 500 type size, where it has a torque of 500 Newton meters across the entire swiveling range. What is the range? Well, actually it's indefinite because of the globoidal design. I can go round and round, so to speak. Now there is the arm which limits this, but otherwise, if there are some special wishes from customers, people who would like to use this as a rotary drive, that would be okay with 500 Newton meters, and I don't have the prior restriction of the toggle lever. And what are the other power stages? Well, that's the biggest one in the family, and we also want to introduce 250 and 125 versions, also with the safety brakes and the globoidal design. Why is this an issue? That is, apparently we need more and more safety features. Yeah, the trend is that I try to install the safety in the unit so that I have less problems with the, let's say, the environment. I don't have to take other precautionary measures if I can do it with the unit as such. So you are realizing that safety is gaining importance for customers. And for this reason, we are also making the product safer and safer. Yeah, that was one of the reasons. I mean, this globoidal swiveling unit without the safety brake wouldn't be redundant, and we wouldn't have been able to sell it in the market.